Good morning, everybody. Today we have to start with a new chapter, which is chapter 13 about alkanes. In this chapter, we will start with the first three objectives about hydrocarbons, definition of alkanes, and nomenclature of alkanes. First, let's start by defining hydrocarbon. A hydrocarbon is an organic compound which is made up from two elements only, carbon and hydrogen. The general molecular formula of hydrocarbon can be represented as CXHY, so it's made up only from two elements, carbon and hydrogen, where X represents the number of carbon atoms and Y represents the number of hydrogen atoms. For example, like C2H6, C3H8, C4H8, all of them are classified as hydrocarbons. While here in C6H12O6, due to the presence of an oxygen element, then this compound, it's not a hydrocarbon. It's an organic compound, but it's not a hydrocarbon. Here we have a chart representing the classes of hydrocarbons. First, hydrocarbons are classified into two categories, aliphatic and aromatic. Aromatic that are represented by benzene. Aliphatic hydrocarbons are classified into two types, saturated and unsaturated hydrocarbons. Saturated hydrocarbons are alkanes and cycloalkanes. Alkanes are acyclic. They are represented by an open chain, where the general molecular formula of an alkane is CnH2n+2. Cycloalkanes, which are represented by a cyclic chain, a closed chain. The general molecular formula of cycloalkanes is CnH2n. Unsaturated hydrocarbons are divided into two classes, alkenes and alkynes, due to the presence of a multiple covalent bond. They are classified as unsaturated hydrocarbons. Alkenes, they contain a double covalent bond in their carbon chain. The general molecular formula is CnH2n. Alkynes, the type of bond is triple covalent bond. It includes a triple covalent bond between carbon atoms, where the general molecular formula of alkynes is CnH2n-2. Here, to differentiate between a saturated and unsaturated hydrocarbons, you can use the bromine test. By streaming an alkane in a bromine solution, the color of the bromine solution remains the same, which means it remains orange. No change in the color of a bromine solution, since alkanes are saturated hydrocarbons, does not react with orange bromine solution. While in the case of alkenes, unsaturated hydrocarbons, a decolorization of a bromine solution takes place. We will observe the formation of a colorless solution. It changed from orange into colorless, which indicates the presence of unsaturated hydrocarbons. Alkanes, so as a result, alkanes are saturated hydrocarbons. The general molecular formula of alkanes is CnH2n+2. They are present in petroleum and natural gas. We have said that alkanes are acyclic hydrocarbons, which means that they have an open carbon chain, but this open carbon chain can be either straight, unbranched, or a branched carbon chain. In a straight carbon chain, all the internal carbon atoms are bonded to two carbon atoms only, while in a branched carbon chain, at least one of the internal carbon atoms, like here, is bonded to more than two carbon atoms. This internal carbon atom is bonded to four carbon atoms. Here it's bonded to three carbon atoms. Alkanes with unbranched carbon chain, so the straight chain alkanes, are called normal or N-alkanes. Let's move to the nomenclature of a straight chain alkane. A straight chain alkane, the name of this alkane is related to the number of carbon atoms in the molecule. Here we have the number of carbon atoms from n=1 till n=10. Beside it, here we have the molecular formula. By substituting n=1 in the general formula CnH2n+2, you will get CH4. The name of this alkane is methane. The same for n equal to its C2H6, its name is ethane, and so on till we reach n equal 10, C10H22, its name is decane. And here we have the condensed structural formula of all alkanes, all straight chain alkanes from n equal 1 till n equal 10. In the condensed structural formula, CH bond is not represented.